So last night I was falling down a bit of a rabbit hole, scrolling through the old Voyager 2 image archives.
That's a fun one.
It really is. And I got stuck on Uranus's moons, specifically on Miranda. It is the most visually chaotic thing in the entire solar system.
It's the Frankenstein moon, for sure. It looks like a jumbled mess, you know?
Exactly. Like someone smashed it into pieces and then just sort of glued it back together in the dark.
Yeah, you've got these huge cliffs next to these weird grooved terrains.
Yeah.
It makes no sense.
And because it's so small, I mean, it's barely a seventh the size of our moon, everyone just assumed it was this frozen dead rock.
Historical relic.
Right. But this new analysis suggests we've been reading the scars all wrong.
We have. The argument now is that this chaotic surface isn't just a sign of a violent past, it's actually the signature of an ocean world.
Which just sounds impossible for a body that tiny and that far from the sun. So let's get into this. How on earth do you find an ocean using a flyby from 1986?
Well, you have to sort of reverse engineer the stress on the surface.
Okay.
The team mapped out all the major features, the cracks, the ridges, the cliffs. Then they ran computer models to figure out what kind of interior mechanics could physically create those exact patterns.
So it's almost like forensic architecture. You're looking at how a building failed to understand what its foundation was made of.
That's a perfect analogy. And the models were surprisingly specific. They showed that if the interior was just solid rock and ice, you couldn't get those features.
It wouldn't work.
It wouldn't work. To create that kind of stress, the ice crust had to be thin, less than 30 kilometers, and it had to be floating on something, on a fluid layer.
On a shifting ocean. And the data suggests this was a big one, too, like 100 kilometers deep.
At least, which brings up the big question, right?
The heat. Where does a tiny, distant moon get the heat to melt that much ice?
It's a process called tidal resonance. The theory is that a long time ago, Miranda was locked in this kind of gravitational dance with another moon, Umbriel.
A 3-to-1 resonance, I think I read?
That's the one. So every time they passed, gravity would stretch and squeeze Miranda. It's like taking a little metal coat hanger, just
bending it back and forth really fast.
Exactly.
Yeah.
And that physical flexing generates friction, which creates heat. That gravitational tug of war was a powerful enough thermal engine to melt the moon's interior.
It's amazing how efficient nature can be with just gravity. Speaking of building efficient systems.
Right. If you're a business looking to integrate AI agents, whether that's for automation or for software development, you really need to build it on a solid foundation.
And that's where Embersilk comes in. You can go to embersilk.com to uncover where agents can actually make an impact for your business. It's all about working smarter.
Yeah, very good point.
So back to that thermal engine. That resonance with Umbriel, it stopped millions of years ago. The heat source is gone.
Which should mean the ocean is gone too. It should have frozen solid. But, and this is a really cool part of the study, the researchers think it might still be there.
How is that possible?
It comes down to basic physics. You know what happens when water freezes into ice, right?
It expands.
It expands a lot.
Mm-hmm.
If Miranda's entire 100-kilometer deep ocean had frozen solid, that internal pressure would have just shattered the surface.
We'd see these huge expansion cracks all over the moon.
All over it. And we don't. The fact that we don't see those specific fractures suggests the freezing process just isn't finished yet.
So there could still be a thin remnant ocean sloshing around under the ice.
It's a strong possibility.
That immediately puts Miranda in the same club as Enceladus, Saturn's little active moon.
It does. Now, Miranda probably isn't shooting plumes into space like Enceladus is, but the evidence for liquid water is compelling.
The implications for habitability here are they're huge. We used to think you needed a planet in the Goldilocks zone near a star to find liquid water.
And this just blows that wide open. It expands the habitable real estate of the solar system. If a tiny battered moon like Miranda can hold onto an ocean for this long,
then life-supporting environments might not be rare at all. They might be pretty common out there in the cold and the dark.
it's an incredibly hopeful sign. The universe is just wetter and more dynamic than we ever gave it credit for.
It really makes you wonder what else is waiting for us when we finally send a proper mission back to Uranus.
It's a treasure trove out there. We've literally only scratched the surface.
I love that. Well, if you enjoyed this deep dive, please subscribe to the show. Hey, and if you can, leave us a 5-star review. It really does help get the word out. Thanks for tuning in.